Hi, everyone. I'm Katherine Ackerman, and I go by Katie. I'm a PhD candidate in the Department of Atmospheric Sciences here at the University of Hawaii at Manoa. Originally, I'm from Buffalo, New York, which is where I started my undergraduate career. But after another year in the cold, I ended up moving to Hawaii to finish my undergrad in geology with a senior thesis in atmospheric sciences. I ended up loving atmospheric sciences so much that I decided to stay here for grad school. My journey hasn't always been straightforward, but I can confidently say that each step has been rooted in wanting to better our understanding of climate change. And so for those reasons, I study sea salt aerosol. I'm sure you've probably never heard of sea salt aerosol, especially in the context of climate change, but I promise that sea salt has big implications for the future of our planet. But first, what even is sea salt aerosol? Sea salt aerosol is just a type of aerosol that's produced by the ocean surface, and it consists of tiny salt particles suspended in the atmosphere. In general, aerosols can play a significant role in how much sunlight the Earth receives, and this is essential to understanding and monitoring our global temperature. Aerosols can also interact with clouds and can change a cloud's ability to rain as well as reflect sunlight. So because sea salt comes from the ocean, this means that they're present in over 3/4 of the Earth's atmosphere, and this gives them a lot of influence over our climate and weather. But despite being almost everywhere, sea salt particles are really unique, and their interactions with climate and weather are still poorly understood. So moving into my research and knowing these limitations, I really wanted to have a micro focus in understanding how these tiny salt particles impact our local weather first. In order to do that, I needed to figure out how much salt was in the atmosphere to even begin with. And so my research started off using drones and kites to measure these particles along the coastlines of our islands. My lab developed a 3D printed instrument and some inexpensive technology to collect these particles at different altitudes and positions along the coastline. And this helps us understand how different environmental conditions contribute to changes in sea salt concentrations and distributions in the atmosphere. For the next part of my research, I'm trying to understand how sea salts influence weather. So I'll be looking at signals and radar data to decipher how different concentrations of sea salt, as well as environmental conditions, contribute to different rain patterns and amounts across the Hawaiian Islands. I'm honored to be an ARCS fellow, and with this money, it's going to provide me the opportunity to purchase more equipment, as well as supplement my income in my future years of studying. Thank you all for your time, and thank you so much for this award. Mahalo.